Okay, class, we're going to do some of the set 2 problems, or just simply review them so that you can see the nature of these problems. You're going to be doing set 3, but they're very similar. Same types of questions, just different problems that they give you. If you look at number 4, tell whether or not each of the following ordered pairs is a solution of the simultaneous equations given. Remember that to be a solution, the ordered pair must make both equations true. So if we look, we actually have 3 sets here. We have the first set that are stacked on top of each other. We have x plus 3y is equal to 10, and we have 4x minus y is equal to 14. That's your first set of simultaneous equations. Your next set to the right is x plus y is equal to 2, x squared plus y squared is equal to 4, and your third all the way to the right is x minus 2y is equal to 6, and you have here y is equal to 1/2 x minus 3. Okay, now you see that's already solved for y, but nonetheless you're going to be able to take your x and y, your ordered pairs here, and plug them into all 3 of these, or all 3 sets, let's say. There are really 6 equations in total. But you're just trying to determine, for instance, in the first one, and let's put it on the board, we have x plus 3y is equal to 10, and we have 4x plus, minus y, and that's equal to 14. And we have the ordered pair 4 and 2, or 4, 2. So that means we have to go plug in these values and see if they work. So I would have 4 plus 3 times 2 is equal to 10, because I put in the x and y value. And I want to determine whether or not this is true. Well, I have 4 plus 6 is equal to 10. So 10 is equal to 10. So it certainly works there. And check that one off. Does it work for the other one? Well, 4 times 4 minus 2. And that's equal to 14. So 4 times 4 is equal to 16, minus 2 is equal to 14. And yes, 16 minus 2 is equal to 4, or is 14. And 14 is equal to 14. So this is true for, for this set. Okay. Now you'd have to go ahead and try that with the next set. Okay. And try for the third set as well. Okay, so you have 3 sets there, and again you have from A to I, so you have quite a few, and this is just to get you thinking in terms of whether or not the ordered pair is an answer for both sets. So you have here quite a bit of math to do, but at the same time this is going to help you to recognize what are the answers, and obviously when they're not answers. Let's turn over and look at page 288, and we have exercise number 5. This exercise is about the simultaneous equations x plus 2y is equal to 11, and x minus 2y is equal to 3. Okay, now what are we being asked? Write the equation that results from adding these 2 equations. So we're simply going to add them, similar to what we did in the examples in the video in the lesson. We're going to solve that equation for x. So again, that's just finding the answer for x. X is equal to. Substitute your solution for x in the first equation and solve it for y. Then we're going to write the solution to the simultaneous equations that you have found as an ordered pair, and then check your solution by finding out whether it makes the second equation true, which is similar to what we did in our examples in the lesson. If you need to know how to do that one, go back to the video and you'll see it there. Likewise, we have in number 6, the 2 diagrams below illustrate a pair of simultaneous equations. So we need to write the first equation, and let's take a look. In this case, I'll certainly go ahead with the example. I know this was a little bit tougher. We had x, 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 and y, so we know that we have 3 x's, and we add a y, and that's going to be equal to 22. Okay, so we have 3 x's and a y is equal to 22. Now below we have 3 x's, but below we have a y and a 14. Remember how we did that? The 10 minus 7? Well, let's do that. We're going to have 3 x's, right? 3 x's. Now, if you wanted to go the other way and take the longer path, you could say that this is equal to y plus 14, right? We could see that. But then what we would want to do is subtract y from this side to bring it over here. So we would subtract y from each side. Hence we would have 3x minus y is equal to 14. Now I showed you earlier in the lesson that, again, if you just look at this as the 10 minus 7 is equal to 3, we wouldn't have to do this particular step. But you can certainly do it. You can certainly write out the 3x on one side is equal to y plus 14, and then just subtract the y's because we want to get the 3x and the y together. So now we end up with this equation. So let me just roll this back a little, and I'm going to, didn't want to do that. All right, let's just roll it all the way back to here and go ahead and write out our equation so that they're stacked one on top of the other. And we had 3x minus y is equal to 14. So we took the two diagrams and we wrote an equation for the first and we wrote the second. I'm sorry, I kind of jumped through because they did want us to write the second one in terms of subtraction. So had we written 3x is equal to y plus 14, it wouldn't have been correct in the end. We had to modify it by moving the y over and show the subtraction that they were asking for. So there's a couple of ways we could have done it. Nonetheless, we still end up with the same answer. Now we're going to solve this for x and y. And you already know by using the addition method, we're going to be able to add 3x plus 3x, positive y, negative y, they eliminate, and 22 and 14 is 36. We divide both sides by 6, and we get x is equal to 6. So now we can use the diagram. It says here we solve the equation for x and y. I'm sorry, we have it for x. So let's pop in our value over here of x into one of the two. Probably doesn't matter in either case. So we have 3 times x. Well, x is equal to 6 plus y is equal to 22. I kind of like this one only because I would have ended up with a negative y over here. So what do we have? 18 plus y is equal to 22. And if we subtract 18 from each side, y is going to be equal to 4. Okay, so we had 18. We'll subtract it from 22. So y is equal to 4. And our ordered pair then would look like this, 6 and 4. And we can use the diagram. They want us to look at the diagram and plug in the values. So if we were to put in the value of x, for instance, we had 6, 6, 6, and we have a y value of 4, sorry, and then we have the 22. Does that work? Well, we have 6 plus 6 plus 6 is 18 plus 4. Yep, that's equal to 22. Let's take a look at the other value, the other diagram. 4, oh, I'm sorry, it's the x value. Let's put in 6 and add these up. We have 6 and 6 and 6, and below we would have 4 and we would have 14. Well, 6 plus 6 plus 6 is equal to 18, and 14 plus 4 is equal to 18. I probably could have done that same here by simply writing that these are all equal. So we can see that when we plug in our values into our diagram, it works. These are correct. This is the one ordered pair that makes both of these equations true. Okay. Now, the diagrams below represent pairs of simultaneous equations. Use the method described in exercise 6 to find the lengths of the line segments of each diagram. So here we go again. We have 7 and we have 8, similar to what we just did in 6. We need to solve these using the same methods. And now we jump up here to the top of page 288. Solve the following simultaneous equations, show your steps, and check your answers. Now we're just going to cut straight to the chase. We have 1, 2, 3, 4, 5, 6 different groups of simultaneous equations. You're just going to solve them, find what your x value is, and then find what your y value is, and check your answers and show your steps. Okay, don't try to do these in your head, and certainly you should be showing, similar to what we just did on this board. You don't have to obviously do any illustrations. We're not using these illustrations, but you saw how we did them in our lesson, and you should be able to show all of that work. Okay, so that is your review of your homework.